syllabus, and the contents of syllabus also just we know very well. Just soil exploration, shallow foundations, bearing capacity, settlements, pile foundations. Okay, so we need to discuss all these things. Initially, just if you see the syllabus, second unit and third unit are there. So these units, soil slope stabilization is the independent chapter. So we need not have to acquire, or just you need not have to know the previous the prerequisites, all those things. And if you see this at pressure theory, in earth pressure theory, just we need the basics of shallow foundations as well as deep foundations. Okay, that's why just at the pressure theories, just I'll keep at the end of or just before completing the syllabus. And just if you see this earth pressure theory, of course, earth pressure theory is required for the different for defining or just the for the explanation of shallow foundations. So these two are interconnected actually. So, but if we take up the earth pressure theories, so the content required in earth pressure theories based on shallow foundation is more than the shallow foundations based on earth pressure theories. So that's why just the less content is required in shallow foundations. That's why I'll take up shallow foundations first instead of lateral earth pressures. So, but I'll discuss the lateral earth pressure required content in the shallow foundations chapter. Okay. So then we'll move to the pile foundations. Then we'll take up the next previous two, second and third chapters. Got it? So our order of discussion is unit 1, then we'll take up unit 4, then unit 5, then I'll come to unit 3, then unit 2. So here the order is like that. So even though in the syllabus the order is given 1, 2, 3, 4 like that, just depending upon the studies or depending upon the dependency of one chapter over the other, I'm taking the order like that. First chapter, fourth chapter, fifth chapter, then I'll come back to third chapter, then second chapter. Okay, so that's the order of discussion in our syllabus or in our content. So first chapter is soil exploration. In the soil exploration, we are going to study the excavation methods and what are the different samplers existing for the excavation of the soil at deeper depths. Then the testing of the soil, depending upon the penetration test, we are going to discuss only 2 or 3 penetration tests, even those infinity penetration tests are available in the study in the literature. Just we will be taking only 3 or 4 tests. Okay. Based on those test results, how do you arrive the soil bearing capacity or the strength of the soil? So once you get the strength of soil, then how to prepare the report, soil report, so that structural engineers may design the superstructure. So this is the order. So soil exploration methods, just if you see any structure, so for any civil engineering structure, it may be multi-storied buildings, skyscrapers, or the earthen dams, embankments, so foot-over bridges, so whatever it may be. So for all those things, just we need the strength of the soil. So here, if you have footing like this, so the wide foundation here, so width of the foundation is more, and here if you have ground level somewhere here, somewhere here, ground level. So this may be the column, and footing may consist of some projection also, but this is the rough diagram. That's why the ground is shown here. So the wide foundation or wide structure is present below the column, then it is said to be shallow foundation. If the foundation is having the lengthy foundation, just you can see this length of the foundation or depth of the foundation is more, then it is known as deep foundation. We will discuss these things later. based on some theories. Okay, so finally what we are going to study is if we have superstructure, so that superstructure loads will be carried over to the footing through some columns. So that load is distributed over the entire area of the footing. So once we have the stress at the bottom of the footing, so that stress must be transferred to the subsoil. If subsoil is having sufficient strength, then automatically, so the structure may sustain. So if the soil below the foundation is having very less strength, suppose let us take loose soil, then the settlement may occur. So if you have any very soft soil, if you place anything or any object on the soil, sometimes it may sink or sometimes it may create excessive settlements, or sometimes it may fail also if the load imposed on the soil is more. So if you have loose soil or very soft soil, in other words, the soil having very less strength, then the soil may undergo failure due to the applied loads coming from the superstructure. Okay, that's why just we should know how much strength the soil has below the foundation. So then depending upon that, then we can restrain the load imposed on the foundation. Okay, based on the strength of the soil only, just we need to plan the superstructure. If the strength of the soil is not sufficient, then we can go for ground improvement techniques also. So that is different criteria. So first of all, we need to know the strength of the soil below the foundation. Is it sufficient to carry the load, superstructure loads or not? We need to confirm. Okay, so for that sake only, just we need to explore the soil. We need to excavate the soil. Then depending upon the excavated soil test results, we can say the strength of the soil. Okay, so this is the concept. So the main foundation or footing is meant to transfer the loads from the superstructure to substructure. Superstructure to subsoil. So whatever footing is there, that footing is known as substructure. Okay. So below the ground level, whatever structure is there, that is substructure. Below the foundation or below the substructure, whatever component is there, so that is nothing but subsoil. And above the ground level, which is visible, is known as superstructure. Okay. So if you have the foundations, width of the foundation more here like this, then we can say that as shallow foundation. If the depth of the foundation is more, then it is said to be deep foundation. Okay. In both the cases, the only thing is that with the transferring of loads from the superstructure is happening to the subsoil. It may be shallow foundation or deep foundation. Okay. Now, in order to know the strength of the soil, we should know the soil characteristics and the nature of the soil and whatever parameters are influencing the strength. So those parameters just we should know. So, but it's not just considering the loose soil. Just whatever you did in the soil mechanics laboratory in those 15 days. So you might have taken the core cutter, the unit weight of the soil you might have calculated in the laboratory. So that is required. So undisturbed soil is required. So that undisturbed soil represents the soil conditions in the field. So almost if not 100%, at least 90 to 95% properties are same as in the field. Okay, so that's why just we need to consider the in situ soil or undisturbed soil from the field. So how to collect that undisturbed soil? So those things just we'll be discussing. Before going to that, so what is meant by in situ? So you might have written in situ unit weight of the soil, so and so in core cutter method and the sand replacement methods in the laboratory. So what is meant by in situ? in situ is nothing but the original position, in its original position, in its field conditions. So whatever properties are there, so those properties are in situ properties. In situ is Latin term. So that is there on the slide. Why we need in situ testing? If we collect soil sample, disturbed soil sample, and test it in the laboratory, is it not sufficient? No, it's not sufficient. So that disturbed soil may not represent the actual condition of the soil. The water content may change, the density may change, hence you may not get the actual properties which are existing in the field if you test the soil sample in the laboratory. Got it? So that's why just we need to perform the in situ testing. What are the objectives of field test? Okay. So are you getting my discussion? Any doubt?
Yes, ma'am.
Okay.
Yes, ma'am.
Then objectives of field test. Of course, I have discussed already. So knowing the general suitability of the site for the proposed works, for the proposed projects. So if we are going for the construction of civil engineering structures, then whether the soil is suitable or not. So we need to confirm from the field test. That is nothing but this. We should know the strength of the soil. Depending upon that strength of the soil, we can able to check with the imposed loads. Okay. Then assessing local conditions and problems likely to be encountered in the foundation construction. So whenever you are going for the foundation construction, is there any local problem? That means, suppose if you are going for 2 cellars or 3 cellars for the construction of the building. So whenever you excavate the soil, some soil may fall, and then you may not cut the soil in vertical direction. It's not possible to cut the soil in vertical. So that's why just we need some sloping nature of the soil. So let it be 75 degrees or 80 degrees. Sometimes the slope may fail also. Okay, so that's why just we need to know the local conditions of the soil, whether the seepage is present or is it possible to cut the soil in vertical direction, exactly 90 degrees or 85 degrees like that, or if you have any wells. So if you see the sites in Hyderabad, almost all GHMC owned sites are consisting of these wells, deep wells. So 20 to 30 feet deep wells may be present. Okay, so for that one, generally people will fill the waste in that wells. Usually just 20 years, 30 years back, if well is there, nowadays nobody was using the well. So that's why just people will generally dump waste in the wells, and that well will be filled with the dumped waste or any municipal waste, any waste. So it may not be consisting of soil also. Only dump waste, cloth material, plastic material, some material may be present in those wells. So if you construct foundations of a structure in that well, so automatically settlement, excessive settlements may occur. So that's why always we need to see whether any well is existing or any stream is existing in the olden days. So all those things just we need to inquire in the vicinity. Okay, so while inquiring, just don't ask the youngsters. So you need to ask the old people. So they only give the exact locations and the